Hello everyone. Let's review for the hypothesis testing. Specifically, this is for one measurement. Um, so this problem is from discussion 24, problem one. So the problem is, let X be a measurement of patient's blood pressure, which follows the normal distribution with the standard deviation equal to 5. Um, and our null hypothesis is that the mu, which is the mean, is 120. And our alternative hypothesis is um, this alternative hypothesis is that mu will be greater than 120, and we are given that the significance level is 0.05, and our measurement, because it is a one measurement test, we only have one measurement at 135. Um, so we want to do the experiment ourselves. The first question comes to our mind is it which is this test? Is it one-sided test or a two-sided test? So for one-sided test or two-sided test, we only look at our null hypothesis and alternative hypothesis. Because our alternative hypothesis is greater than 120 instead of not equal sign. This is one-sided test. If our alternative hypothesis is instead changed to not equal, then this is a two-sided test. So um, So there are two ways to solve this problem to draw conclusions. The first way is to check p-value is check p-value versus the significant level. If the p-value is less than the significant value, if p-value is less than significant value, we can reject the test. If it is not, we cannot reject our null hypothesis. So the way we do that is because we know that it follows the normal distribution. So we kind of like standardize this normal distribution by calculating the z-score, which is x minus mu divided by sigma, which is 135, our measurement, minus 120, which is the mean, divided by our standard deviation 5, which is, so we calculate the z-value equal to 3. And then we check the z-score table, and then we will find the p-value corresponding to we will find the area corresponding to the of 3, which is 0.4987. Like I would like you to use a graph to visualize what is happening here. So we basically look at 3 standard deviation of both mean. So that's this line here. And our z-score is defined to be the area here. So this value corresponding to area here, and this value is where you check the z-score table. But we want to know what we want is this area, and this is p-value. So we know that because normal distribution is symmetric, only half of the value areas lie on the right-hand side. So the p-value, which corresponds to the area of the tail, is equal to 0.5 minus 0.4987, which is 0.0013. And clearly, 0.0013, which is the p-value, is less than 0.05, which is the significant level. So we can draw the conclusion of rejecting the null hypothesis. And another way to solve this problem is by looking at the critical value. So the critical value is basically the boundary of the rejection zone. And then we want to say if our measurement lands inside the rejection zone or not. So for this question, we set k of critical value So we set an unknown variable and we want to solve for z. And we know that the boundary of rejection zone is 0.05. A graph representation of that will be this is a normal distribution, and we have a boundary for rejection zone, and the value of that is equal to k. And the area on the right of this rejection zone is equal to 0.05. So if a value that is greater than k, if there's a value that the measurement is greater than k, it has to be lying in the rejection zone. And that means we should reject the null hypothesis. And the vice versa. If it is didn't lie in the rejection zone, we cannot reject the null hypothesis. So the way we solve this problem is to again using like z-score to standardize it. We know that this area is 0.05. So which means that so this means that this area is 0.45. So we essentially want to calculate the z-score of k equal to 0.45. Or like the z-score of k after standardization, because k is our measurement value instead of, or theoretical critical value instead of a value in the scope of z-score. Going to first standardize Z2 minus the mean, which is 120 in this case, and divided by the standard deviation, which is 5. So we kind of are doing the reverse engineering. We look at the Z table and we find which value if we input into the z-score function, and we will end up getting 0.45. So after checking it out, it will be 1.65. So z, we know that z of 1.65 will be 0.45. And so we know that k minus 100 divided by 5 has to be equal to 1.65. So we solve k is equal to 128.65 or 128.25. So that's our critical value and that's our boundary. However, we know that our measurement is 135, which is greater than 82.25. So it should lie in the rejection zone. And then we can draw the conclusion that we were to reject our null hypothesis. So I present two ways of solving this problem.